Okay, so just do the first sentence. A rational expression is a quotient of two polynomials. So I will post the PowerPoint for you. And so, like, if you want to do the definition for your Avid notes or something, then, you know, copying the definition, you can do that without me. But I want to make sure we have enough examples for you to practice and have to look at when you do your homework. So again, when you do your homework, have your notes out. It just makes it easier. Look at what I did first, look at what I did second. So that way you're just not staring at the problem like, oh, I don't know where to get started. Because chances are you get started in the exact same way. Okay, so I'm going to change the slide, but I will put it on haiku, so just skip a little space so you can get the definition later. This one is not as long, so just make sure you copy all of this one. So we just went over it again, but I think, you know, keep going over it, it just makes it easier. So an excluded value is any number or numbers that make the value of the denominator equal to 0. So is the denominator the top or the bottom of the fraction? The bottom. So make sure that if you don't normally use denominator, just make sure you write that it's the bottom. Okay, and this value, like we went over with our warm-up, is where our function is undefined. So wherever or whatever numbers make the bottom 0, those are the values that make the function undefined. So before we get into actually multiplying rational expressions, we're going to go over how to do it with numbers. So there's two ways that people multiply fractions. So you guys should just go ahead and shout out, how would you multiply 4 over 3 times 6 over 16? So what numbers would you guys multiply together? Okay, I guess I'm just... So if you want to write that there's a second essential question, you would just change multiply to divide. Just change the same one on the front, just change multiply to divide. All right, so when you divide fractions, and so this I would copy down. When you divide a fraction, we don't know what to do with that. Like, how many times does 3/4 go into a half? Well, I don't know. So what we do is we change division to what? Multiplication, and then we take the reciprocal of the second person, so the one in the back. So 1/2 divided by 3/4 becomes 1/2 times 4/3 or 4/3. So you change division to multiplication, and then you take the reciprocal or flip the second fraction. So make sure that you know it's the second one, because if you flip the first one, that's wrong. Or if you flip both of them, also wrong. So just make sure you know which one flips. So you could do the same thing, like 2 goes into 4 2 times. Then the 2 on the bottom left would cancel out. And so you would actually get that your answer is 2/3. So yes, you could have done 1 times 4 over 2 times 3 and then simplified. But again, because we're dealing with rational expressions, what you really want to do is simplify first by taking out common factors, and then whatever's left over, you would multiply together. So our first example is going to be another one with monomials. So that means you don't have to factor. But let's just go through the steps. So we change division to what? Multiplication. And then we take the reciprocal of the second one. So I would recommend doing that first. So the first thing I would do if you see a division symbol, change it to multiplication, and then take the reciprocal. Because if you try to factor first, if you have to, in this case we don't, some of you might do all the factoring and then forget to take the reciprocal. And then you'll be freaking out because chances are nothing's going to cancel. Okay, so in this case it's color-coded for you, so it kind of tells you what's going to have to happen. But I know 5 and 15 can both be divided by what? 5. So this 5 would go away, and this 15 would become a 3. And then what would happen with my 8s? They would cancel out. And then after that, I would go ahead and do the x's. So this 5 goes away. That becomes a 3. X to the 4th divided by x squared means the top piece becomes x squared. Then let's do our y's. Y to the 5th divided by y squared leaves me with how many? So y to the 5th divided by y squared leaves me with y to the 3rd. And then we already knew our 8s went away. So once you start canceling stuff out, then you rewrite it and put it all together. So we had x squared left over on the top left. We had y cubed left over on the right. So the top is x squared y cubed. And then on the bottom, everybody went bye-bye except for that 3. So does anyone need more time with this example? All right, so I'm going to have you copy it down first. Okay, and this is where, if there's not enough space, although I think we tried to space it out where you'd have plenty of space to do it, if you write bigger, I would just use a separate piece of paper and attach it. So you want to make sure that you can tell where your steps are, and that I can tell too. So we have x to the fourth minus 9x squared divided by x squared minus 4x plus 3. And then that whole expression on the left is going to be divided by x to the fourth plus 2x cubed minus 8x squared over x squared minus 16. So what's our first step? We change division to multiplication and then take the reciprocal of the second one. So this needs to be flipped. Okay, and then here's where it's going to determine how much time is this going to take you. So if you can factor fairly quickly, then it won't take you that long at all. If you need more practice on factoring, this is where it's going to take you a little longer. So again, I recommend practicing some of the factoring, like this one, which is a difference of squares. So something like this, I would expect that we could factor in under a minute because it's a difference of squares. So then let's look at the left side. What can I take out of both of these? We could take out an x squared. So I just want to show you, because once I click the PowerPoint, it's going to go through really quickly. I want to show you where they got everything. So it's going to be x squared, and then we're left with x squared minus 9. And I think we already factored this today as well. So this is a difference of squares. If you can factor a difference of squares quickly, you're making your work faster, a little less stressful. What do I do with something like x squared minus 4x plus 3? What method do we use? The x method, or if you like the table and the box method, whichever one you like best. But this is a quadratic with 3 terms, so you need to use that method. This is a difference of squares. And then this guy, what could I factor out of all of them first before I get started? We could pull out an x squared. So then that bottom piece will be x squared plus what? So if I take out an x squared from this guy, what's left over? 2x. And then what's left over with the last person? Just the 8. So if you're having issues with the factoring, chances are it's because you're not taking out a number first, or you're not noticing if it's to the third power or to the fourth power. So if you have anything that's to the third or fourth power for this unit, you need to factor out a letter before you get started. Okay, so then I'm going to put the next slide so you can see how they factor. So again, both of the numerators, I would say you should be able to factor down a minute, 2 minutes tops, because they're difference of squares. They're perfect squares. So this is x minus 3 times x plus 3. This is x plus 4 times x minus 4, and it doesn't matter which guy's first. So if I gave you x squared minus 25, I expect that you can tell me, well, it's going to be plus 5 and minus 5. Or if I gave you x squared minus 100, it'd be x plus 10, x minus 10. So if you know that detail, then you just saved yourself a bunch of time factoring those numerators. So now that everybody's fully factored, what's the second step anytime I'm doing a multiplication problem? Divide out the common factors. So on the left side, they're already showing you that you have x minus 3 on both the top and bottom. And then on the right-hand side, you have the x plus 4s. And then in the top left and bottom right, you have x squared. So all of that stuff is going to leave. So the x squares go away. The x minus 3s go away. The x plus 4's go away. So then what's left over on top? So on the left, I'm left with what? So x plus 3 on the left, and then on the right, I'm left with x minus 4. So now I'm putting them together just like we did earlier. They need to be multiplied. What's left over on the bottom? So whatever's left together, that's when you start doing the multiplication. So I did x plus 3 times x minus 4 because they didn't go anywhere. X minus 1 times x minus 2. They didn't get canceled out, so they have to stay. And then just leave it there. So yes, you could do a box and tell me what x plus 3 times x minus 4 is, but just don't. Just leave it like that.